Hi, welcome everyone to the second session of session 10. And in this session, we will look at finding neighbors, little deep dive. So in the previous session, we built a KNN model and we validated on the test data. So when we gave a test data or data point, it found the neighbors, and based on the neighbor's outcome of the price, it predicted or estimated the price of the new data point in the test data. But which are these neighbors? How do they look like? How similar they are to this test data point in terms of attributes, right? So let's look at some deep dive. So this session will give you more intuition and better understanding of how the KNN model actually works. So for this session, again, I have uploaded a notebook called KNN Finding Neighbors Deep Dive v1.ipynb. So let's open that notebook, Finding Neighbors. So two key topics here: how to find neighboring examples from data set, and of course it will deep dive into how the KNN estimates the outcome of a new data point. So let's quickly run through this data set. So we'll load the data set, the final cars Maruti, and we are selecting this 6 features here again for this particular example. And so one of the things that we can do is, after going through the session, you can actually rebuild all these models with the full feature set, all the features. So that is an assignment for you. And the cat features and the num features here, and set the x and y variable. And we'll create a pipeline for feature transformation like we did last time. So we'll import all the required classes. We'll create a one-hot encoding for encoding the categorical features, and min-max scaling for scaling the numerical features here. And we'll create a column transformer which maps the numerical transformer to the numerical features, and categorical transformer to the categorical features here. And we are not building a KNN model here, rather we are just trying to figure out what are the neighbors here, and from that we will estimate, will calculate the outcome variable here, which will give us a little deep dive into how these estimates are made. So this notebook is primarily purely for the better understanding of the KNN. So finding nearest neighbors, there is another class implementation called nearest neighbors. That's all. It's not a regression or classification. So simply finding the nearest neighbors. So we can import that scikit-learn neighbors nearest neighbors, and we'll initialize with 5 neighbors here, because it's just for pure understanding. And then we'll create the pipeline for the pre-processing. Okay, so we are not including this as part of the pipeline, because once you process the data, we will just utilize this to find the neighbors. So in the pipeline, all that we are doing is we're taking the data, X data. We are not even splitting the data here. We're taking the complete data set to find the neighbors and transform it. Right? We'll just do a one-hot encoding and min-max scaling. Right? And then in this case, we'll fit the whole X and transform it. And the whole data, X data, has been transformed, and let's store that into X data here. Okay, and then we'll fit the X data. So here the transformation is done in X data, and what now we'll do is, we need not do so. We'll just do a fit X and transform it. This is not required. And then now let's say we take a new example. So out of this 1010 samples that we have in the X data, so if we ask a question saying that which of the examples or samples in the complete data set are nearer to this new data. So let's say I take a hardcore example saying that I have a car which is a diesel car, the fuel type. It is a manual transmission. It's a first owner. It's Ertiga model, and the age of the car is 8-year-old, and it has been driven for 87,000 kilometers. Now, for this particular sample, which of the examples in the data, right, in the complete data set are nearest or very similar in terms of attributes, right? And how many neighbors that we've already mentioned here, 5 neighbors. We're going to figure that out. So we'll do now what, we'll take this data which is specified as a dictionary, and we will convert that into a data frame, and then we'll run this nn k neighbors. So here nn is my nearest neighbors, so it has a function called k neighbors. So can you find the k neighbors to this particular data point? So we are also transforming it because this data also need to be transformed, scaled, age and kilometer driven, because my X data is also transformed. So in that case, we will find the minimum Euclidean distance to figure out who are the nearest neighbors. And how many neighbors? 5 neighbors. And we are also asking you to return the distance from this data point. So what it does is it returns a variable, let's say it returns information which you capture in the variable called neighbors here. And in the neighbors, it returns 2 arrays now. You can see this is the first array, this is the second array. And here you can see these are the indexes. So out of the 1010 samples that we have, it's saying that the first sample, the 298th sample, 338th sample, and all these 5 samples are the nearest to it. In this particular, so to this particular sample that we are given here, in the actual data, these are the nearest ones. It has already estimated that. And the distance between these samples are this. So this is almost 0, very, very closest. This distance is 0.005. These are Euclidean distance it is calculated. Okay, so this is the distance calculation from the sample, this particular sample, and these are the indexes of the samples. Now what we can do, we can take this particular indexes, which is the index list, 0, 298, 338, 886 and 234. And this is the original data that we have, test sample data that we are given. So the car is diesel, manual first, 8 Ertiga and 87. Now in the X data, we will only look at those samples whose indexes are this, right? We'll just filter those out. Now if you look at this, now these are the examples that it has, the neighboring algorithm has figured out from the complete data set, is saying that they're very near to this. And if you look at the first example, is very same, is exactly same, diesel, manual, first, 8 and 87. That's why he's saying the distance is 0, exact distance. Okay, not necessarily in all the time we will actually find this very similar example, right? And if you see, interestingly, based on the data that we have given, it has figured that out, the nearest ones, all the diesel cars, because it's a diesel car. all the manual cars and all the Artica models only, because that seems to be, and all the first owners. But in terms of age, maybe not everybody is 8. So it figured out, okay, this is 8, this is 7 and similar. And kilometer driven, 87, 70, 88, 82, 75. These are the nearest ones, right? So how interesting, it has figured out which are the nearest example. And from there, now let's say we'll go look at what is the price of this one, at which price this car was sold, at which price this car was sold, right? We can now look at the prices, and then what you can do is we can estimate, we can take an average of it. So P1, P2 plus P3, P4 plus P5 divided by 5, we can estimate the price of it. So here we have done same thing. We have taken the same indexes in the Y as well, the prices. So these are the, so Y is, so we'll take the Y values, it's not Y train, Y, Y index is in neighbors index, same indexes 0, 234, 298 and all that, and these are the prices P1, P2, P3 and all that. And all we have to basically do is what? Take an average of all that. So let's change that to Y. So it comes out to 6.07. So if you remember, in the session 9, we did the same thing, and it came out to be exactly 6.07 lakhs when the model is built. But this is how the price is actually built. So if we take let's say take a separate example, let's say age is 3, and let's look at Swift model, which is driven for, let's say, 50,000 kilometers, and it is petrol, and it is automatic. Let's say we'll take this data now, and now you see that now it has figured that out. So now these are the indexes of the examples which are nearer to this particular data point. And if we go and look at those cars, and we can see these are the cars, the petrol cars, automatic, most of the automatic is the one is of course manual is found out, Swift cars, and they actually figured out other models here. So it actually did not find enough Swift cars in this case. Maybe we'll look at diesel here. Yeah, so in this case I think it found most of them are diesel Swift cars, all the first owners, and it only found 4 automatic, 1 manual. Of course there's something did not find all the neighboring examples here, but you can see most of the neighbors have a very similar attribute to this particular car, and then you can estimate price from that. So this is an exercise that is given to you, like we did, estimated the price based on the uniform weights. So it took the price of all the cars here and just took a simple average of it. So now can we calculate the price based on the distance? So if you remember, in the uniform weights, what we do is we predict the y value by taking the k neighbors. We're taking the simple average of all the y values of the neighbors. Now if we leverage the distance itself, for example, this also returns the distance, how much distance or how far are these neighbors from this particular sample here. So let me revert this to the previous sample. Now if you look at these are the distances 0, 0.005, 0.029 and all that. Now what you can do is, can we leverage these distances to estimate the price based on the distance weights. So what will happen is, now in this case we can estimate the price of the car Y and then take the y value, in this case the price, divide by the distance and 1 by k. Not 1 by k. So this should be not 1 by k, divide by the summation of 1 by di. So that will be the weighted average calculation of the y value. So I'll leave that as a participant exercise. But one thing you have to keep in mind, because we are dividing 1 by di, if at all we find a nearest example which has a distance of 0, okay, so that will become 1 by 0. So that will result into arithmetic overflow, right? So what we do is, in that case, when we divide the price by the distance, you add a small value to it, like 0.002 or something, right? So that way what will happen is 001 or 002, or a small value. And in this case, a small value like it could be 1,000 rupees, 01. Okay, so that will ensure that it does not lead to the arithmetic overflow. So participant exercise, find the estimated prices of the above test sample using weighted average now, and use distances written by the NN neighbors to estimate that. Okay, so this will be a good exercise for you, and we'll see you in the session 11. Thank you.